Good afternoon. Welcome to today's TASA webinar, Hand and Power Tool Safety. Hand and power tools are a part of our everyday lives and help us to easily perform tasks that otherwise would be difficult or impossible. However, these simple tools can be hazardous and have potential for causing severe injuries when used or maintained improperly. Special attention toward hand and power tool safety is necessary in order to reduce or eliminate these hazards. Employees using hand and power tools are exposed to hazards of falling, flying, abrasive, or splashing materials, as well as harmful dust, fumes, mist, vapors, and gases. They should be able to recognize the hazards associated with different types of tools and the safety precautions necessary. Employees should be trained in the proper use of all tools provided with appropriate personal protective equipment to guard against injury. During today's program, our presenter will cover the safe use of the following: hand tools, electrically powered tools, abrasive wheels and tools, pneumatically powered tools, liquid fuel tools, hydraulically powered tools, and power-actuated tools. The presenter for today's program is David Doddridge. David has over 50,000 hours of hands-on construction, building inspection, and consultation experience. As an expert, David provides attorneys with expert consultation services in the following areas: personal injury, construction accidents, OSHA, construction defects and damages, building codes, and building inspections. David performs site inspections, writes expert reports, and presents expert testimony. During our presentation today, we will have 2 question and answer breaks. If you have a question, we ask that you use the chat feature or the Q&A feature, which are found on the right-hand side of the screen. I pointed them out using my pointer. Tomorrow morning, we'll send out an email with a link to the archived recording of this webinar, and we do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I now invite you to sit back, relax, and enjoy. I'm going to turn the program over to our distinguished presenter, David Doddridge. David, the program is now all yours.
Well, thank you, Matt, and good afternoon, everybody. Thanks for joining us. Today we're going to be covering power tool safety according to OSHA regulations. The primary goal for you, I think, today would be to have a better understanding of the hazards related to power tools. If some of you are involved in representing injured workers, then this program should be able to give you some insight as to perhaps what to look for immediately after a construction accident. Oftentimes the tools are discarded, or maybe they belong to somebody else, or whatever the case may be. So this hopefully will give you a better understanding of information and data to collect when you get a client who's been injured on a construction site. So with that said, let's move on here. Some of the hazards that are associated with power tools are objects that fall. For example, if maybe you're working on a wood frame of a house or a commercial building, and you're cutting something out overhead, and it becomes loose and falls down upon you. Things that fly, of course, sawdust, abrasive, being like perhaps metal shavings, and this can happen on any construction project, big or small. And of course, associated with power tools is the possibility of electrocution. Next slide. Basic tool safety rules. Obviously, maintenance, using the right tool for the job. I have a case, for example, in New York, in the Bronx, where a gentleman was using an improper tool to cut out the mortar in between bricks on a school project, and the tool kicked back and severed his wrist. He was injured pretty badly. So you have to choose the right tool for the job, of course. That doesn't always happen. Personal protective equipment, of course, is known as PPE, meaning dust masks, gloves, goggles, eye protection, that kind of thing, and of course using guards that typically come with the tool. Some of the hazards of hand tools. The obvious, you know, the head of a hammer can come flying off if the handle is damaged. In that picture right down, oh, hang on a second. Right here, it shows that the head of the chisel is what's called mushroomed. And when you're striking something like that, a piece of metal can come flying off of that chisel, and you're striking a surface that is obviously worn. The hammer that you're striking with can flip off as a result upon impact, and you could break a finger. Proper protection for the use of hand tools. The obvious safety goggles would certainly be at the top of the list. Guys don't always use gloves. It's a little impractical to always use gloves when you're using power tools, just from an ergonomic standpoint. So that doesn't really happen too often unless you're using a jackhammer or something else. But you don't often see guys using gloves when they're operating a circular saw or a power drill or anything like that. Keeping cutting tools sharp is really important. A dull tool is far less safe than a sharp tool is. For the reason being, for example, if you're cutting through a piece of wood with a circular saw, if the tool isn't sharp, then you're going to have to use more force. It's not going to work as intended, and so therefore it becomes more dangerous as a result. The safety switch on a power tool is a switch that you have to keep constant pressure on. So in other words, you just don't turn it on and it starts. Some tools, of course, do. But a safety switch is one where if your finger is not on it, then it does not operate. Power tools. Power tools must be fitted with guards and, as I said, safety switches. Different types of power tools, of course, electric, like a router, a drill, a circular saw, table saw, that kind of thing. Pneumatic, of course, is powered by air, as in the picture right here. This is a pneumatically powered nail gun. Liquid fuel, of course, would be something like a chainsaw. Hydraulic tool would be something like perhaps a jack if you're jacking something up. And the last one there, powder-actuated, means that it's actuated by a charge made of gunpowder, like the types of nail guns that you see that are meant for fastening things to concrete or to steel. All right, switches. A constant pressure switch, as in this photograph here, means that your finger has to always be depressing the switch in order for the tool to operate. Once your finger comes off that switch, then the tool stops. An on-off switch, some examples, of course, are a router that you would route a piece of wood with, a planer, other different types of tools where the switch is just simply on or off. Those are the ones that you have to obviously be a lot more careful with. Some of the precautions for power tool safety. Number 3, for example, to secure the work with clamps or a vise, freeing both hands to operate the tool. That's fine in a perfect world, but that doesn't. That oftentimes does not happen. When you're working on a construction site, it's difficult to clamp down every piece of wood that you're working with. Time is money on a construction site, so therefore, guys don't always stop. As a matter of fact, they rarely stop to secure a piece of wood in place. Number 4, don't hold the switch button while carrying a plugged-in tool. Believe it or not, this happens often. On a pneumatic tool, for example, a pneumatic nail gun, when you press that switch, if the nose of the tool is not pressed up against the work, there's an actuator on the nose of the tool that has to be pushed in order for the nail gun to fire, and that's a safety precaution. But you see guys walking around construction sites all the time, and they're carrying a nail gun, and their finger is on the trigger, and the only thing that tool needs in order to fire is to be pushed up against anything. It doesn't have to be a piece of wood. It could be pushed up against a guy's leg, and I've heard of that happening before. He hits the nose of the tool against his leg while his finger is on the trigger, and it shoots a nail into his leg. So, again, in a perfect world, fine, but in a practical world, these things happen often. Electrical cords on power tools, again, don't carry the tool by the cord. Don't use electrical cords to hoist or lower the tools. That happens all day long. If you're on a floor above another worker and you need a tool, or you need to pass your tool down to him, it's pretty impractical to climb all the way down a ladder and personally hand it to him. So oftentimes they'll just use the cord to lower the tool down to the next level. And again, these kind of things happen all the time. You're not supposed to do it, but that doesn't mean that people don't do it. And by the way, I'm going to try to make this last about 45 to 50 minutes. We're going to have a Q&A after slide 12, and again after slide 23. Hopefully we'll be able to squeeze an hour out of this. All right, now electric power tools naturally have to be grounded, basically double insulated. A ground simply means the ground this is a grounded cord right here. This is the ground, and what that means is that any overcharged electricity from the tool gets placed back literally into the ground. The plug that the tool is plugged into when you're setting up, or when you have an electrician set up power to the job site, always grounded. Double insulated basically means, and tools are going to be marked right here, double insulated. That means that the tool has internally 2 layers of insulation around the electrical parts, independent of each other. So basically, as the tool gets used, as the tool gets worn, maybe it gets dropped, this is a precaution from the electrical charge being transferred to, say, the handle or to some outside metal part. I've gotten shots by old tools before. Way back in the day, they used to make them not out of plastic, but out of metal. And I remember picking up a circular saw one time and getting zapped. So that's what double insulated means. Good precautions for the use of a power tool. That tool right there, this is what they call a worm drive circular saw. this is what the pros use. This is what I use all the time. They're very heavy. They last forever. They're an excellent tool. Using gloves, as it says right here, again, that's impractical. I rarely see guys using gloves with power tools. It's just they get in the way. Shoes, fine, but gloves, not really. Obviously, don't use in wet locations. That's impractical. I've framed in the rain before. You know, you have to make money. You can't just dry out a job site. So these things are OSHA regulations, but that doesn't necessarily mean that they always happen. Same thing with item number 6. Ensure that the cords don't present a tripping hazard. If you go onto any construction site, there are cords and hoses everywhere. So a lot of these regulations are obviously in place for safety reasons, but they don't often happen. Abrasive wheels. This is something that you would use, say, to sharpen a tool with, sharpen a chisel with, whatever. This is the guard. The spindle end says right here, cover the spindle end, nut and flange projections. That would be right in here. Spindle is the metal rod that the wheel turns around, attached to the electrical motor. Let's see here. Now that was slide number 12. So are there any questions at this point?
David, we do have some questions that have come in. So we'll take a brief Q&A question break, and for all the attendees out there, if you have any questions for David, please use the chat feature or the Q&A feature to submit them, and we'll get them to him as quickly as possible. David, in reference to slide number 5, we have a question in here where he talks about tools should be kept sharp and maintained properly. Are there any sort of regulations or guidelines for sharpening and maintaining your tools, or is it kind of known throughout the trade how to do that properly?
Yeah, I mean, basically the regulation stops right there. You know, keep cutting tools sharp. I don't know that there's a specific regulation for it, but that's just something that anybody experienced in the trades is going to know. I usually have taken my tools to a professional tool sharpening service, saw blades, hand saws, chisels, that kind of thing. So I usually sub that out to a pro rather than doing it myself.
Okay, great. And then we have another question here. Again, it goes, I guess, back to the best practices, or if there are any additional things that you can think of. What's the purpose for grounding, and are these tools double insulated, or how should one go about grounding, and what are some of the best practices?
Well, you have to make sure that the tool has a 3-pronged cord on it. That's step 1. And you also have to make sure that the power that's connected to the job site, that's powering the job site, has been installed by a licensed electrician who's provided a grounding source for that service. Grounding basically means that any excess power to the tool, or if there's a short within the tool, it takes that excess power and puts it down into the ground, and there, of course, it dissipates into the earth. So it's a safety precaution, and it's a regulation, and it's absolutely necessary.
Okay, excellent. We do have a question here from Myrna, who asks, are there any rules or regulations for the removal of guards on a table saw?
Yes, don't. You're not supposed to remove guards from a table saw, although everybody does. I had a framing contractor years ago who would remove all the guards off of the handheld circular saws. Pretty sure there's a picture of a circular saw in here somewhere, because they got in his way. this is the guard right here. That guard's the blade. And he would remove those. So it was just a bare blade. And the reason is when you're holding a piece of wood with one hand and cutting into it with the saw, for some guys, the guard gets in the way, not only visually, but it also, if you're cutting like on a very sharp angle across a piece of wood, the point of contact with the blade, the guard comes in contact with the wood first, and sometimes you can get hung up on it a little bit, and it throws you off your mark. So sometimes what I've done many times, and certainly not something that you're supposed to do, is well, I'll get to it. I'm sure at some point we'll find a regular circular saw in here, but basically what we would do is we would open the guard and jar it open by sliding a pencil in between the handle of the guard and the case of the tool, therefore keeping the guard open at all times for that reason. It's just if you're making a really accurate cut, the guard just gets in your way. As far as table saws is concerned, I've seen lots of table saws used on the job site with the guards removed, and oftentimes for the same reason. And this is just what happens. They're there for a reason, but guys don't always abide by the manufacturer's rules or by OSHA regulations. You know.
Okay, great, David. We have a question here from Ronald who asks, what about trigger locks? Don't they violate the rule about stopping with release of pressure? Trigger lock, I'm assuming what you're talking about is on like a pneumatic tool. I'm not sure if I know what a trigger lock is in reference to a power tool. A trigger lock, like on a gun? I'm not sure if I understand the question. Okay, I've asked Ronald for clarification over the chat feature, so hopefully we'll get back. What was the second part of the question? The trigger locks? Okay, what about trigger locks? Don't they violate the rule about stopping with release of pressure? Violate the rule. I'll ask for clarification. Yeah, let's get clarification, and I'm happy to follow up by answering that question. Absolutely. Yeah, definitely. So let me try to get some clarification from Ronald, and why don't we continue on with the presentation content, David? Yeah. Okay. Hang on. Thanks. I'm just making note of that. Okay. Slide number 14. Inspecting abrasive wheels. It's really very simple. You smack it with a tool, and if it rings, then it's fine. If it's got just a thud, then most likely there's a crack in there somewhere. Does this? Do people do this? Do they think to do it? Not necessarily. But it's obviously it's a good way to test it. Abrasive wheels. Maximum speed says right here. You have to match the max speed, which is typically in RPMs, max RPMs, in this case 4,000, with the tool. Again, the case that I had in Brooklyn was the gentleman actually was using an abrasive wheel. He was using a concrete cutting blade on a grinder that was meant for abrasive grinding, and he took the guard off, he took the abrasive blade off, and he put a concrete cutting blade on it that was too large for the tool. And this is a heavy tool. I actually operated it myself, tested it myself, and it came kicking back on him and severed his wrist. So it's pretty dangerous. Just a lot of it's common sense, but that doesn't always happen.
Now this is an abrasive wheel that's being used for, say, for example, tool sharpening. I'm not sure exactly what that is, but the distance in between the plate and the wheel needs to be kept at 1/8 of an inch, and that prevents the item that you're sharpening from getting lodged down in between the plate and the wheel itself. Guarding, of course, guarding of tools. This is a gasoline-powered concrete or asphalt cutting tool here. And it's just, never remove a guard when the tool is in use. I don't think I know anybody who would ever attempt that. Guarding, this is the guard right here. This is a radial arm saw. And this is the guard here, this plastic piece. This arm right here and this arm right here hold the guard to the tool. And as you draw, this is the handle, as you draw this tool in this direction, the work rests right in here, and the blade comes in contact with the work, as does the guard, and the guard will then lift up as it comes in contact with the piece of wood that you're cutting. Guarding protection. Now this is what's called a nip point right here. When this tool, this is a belt sander. This right in here is an abrasive belt, and this is typically used for sanding wood, sometimes metal. When this tool is in use, this is spinning here, right here, and this piece of sand, basically it's a piece of sandpaper, is spinning, and the work would be down here underneath the tool. So there is a chance that your part of your body could come in contact with what's called the nip point. Things moving pretty quickly, so that can cause some damage to you. Another radial saw. Again, this is the guard right here. As the tool is drawn out across the work, this comes in contact with the work and will lift up, allowing the blade to cut through. Here we go. Right here is the handle that you use to pull back in this direction. It's attached to the guard, so if you need to change the blade, naturally you would unplug the tool first, and unbolt the blade right here. In order to get that blade out, it comes out in this direction. So you need to pull the guard back. These guards can get in your way if you're trying to make a very accurate cut on a piece of trim or even a piece of framing. What you'll see all the time is what we'll do is we'll draw this all the way back, exposing the entire blade. We'll take our carpenter's pencil and wedge it right in here in order to keep that guard back. You're not supposed to, obviously. It makes it more dangerous. But this is the kind of thing that happens on the job site all the time. As I mentioned earlier, my framing contractor from years ago would simply remove this entire guard because they just got in his way. And this is the kind of thing that sometimes guys do on the job site. So hopefully, after you learn from this course here today, you'll know perhaps what to ask, what information to gather when you get a client. There's a table saw right here, table saw right here. That is the guard right here and right here. As the work is being passed underneath the guard lifts, and these oftentimes get removed as well because, you're looking down in this direction upon the work. And if you've got a very specific, and you always do, of course, marking on the piece of wood that you're cutting, you can't necessarily see it. The guard will get in your way, and causing you to maybe shift your body position so that you can see, and that causes other hazards. So I've heard from lots of carpenters that they think that the guards actually make it more hazardous if anything, for that reason, but they are not to be removed. We're going to have a question and answer after slide 23. This is a pneumatic tool powered by air, compressed air, usually nailers, staplers, roofing guns, siding guns, some drills, main hazard getting hit by a tool attachment or by a fastener the worker is using with the tool. And again, this isn't a real good example, but out here at the nose of the tool, this is where the fastener projects out of. And on pneumatic tools, this has to be touching the work, and then you apply pressure to it to cause it to retract a little bit, which is what allows the fastener to project out. And here's the trigger. If you've got your hand on that trigger, the trigger has no real pressure to it. It's just very easy to pull. There's nothing to it. So I've seen guys walking around the job site with their hand on the trigger, and again, if they accidentally press this up against their leg or a coworker's leg or whatever it may be, and if their hand is on the trigger, then that nail is going to come shooting right out of there. All right, we have another brief Q&A here. If there's any other...
and Ronald did provide some clarification. So let's go back to his question, David. His original question asked, what about trigger locks? Won't they violate the rule about stopping with release of pressure? And then he gives the example, electric drills have a button that locks the drill in the position without a finger on the trigger. Is this a product liability issue?
That's a good question. There are a lot of tools that have a locking mechanism. I can certainly check into that. There's other tools as well. The first one that comes to mind is a router. A lot of routers or laminate trimmers are either on or off. And I don't know, but I will certainly look into that, and I will email the answer to that question to the person that's asking it.
Okay, excellent, David. I will pass on his contact information to you.
Okay.
We have a couple questions that have come in, and I do encourage all of the attendees to please use the Q&A or chat feature to send in your questions. We do have some that have come in since the last question and answer break. What is the previous slide to the question slide that is currently up? You briefly went over what a pneumatic tool was. Could you go into some greater detail to explain what a pneumatic tool is, how it works, and where the risk is involved with using a pneumatic tool?
Yes, of course. Let me get to the. Let's see here. There's a. Yeah, perfect. Here we go. This is a very, very typical pneumatic tool. This is a nailer. This is a framing gun. You can't really see it, but there's an air hose attached right over behind this. This is where the nail clips, much like a gun, a handgun. You slide the clips of nails down in here into this carriage, and there's an air hose fastened to it that provides compressed air to the tool. And in here, right in here, is a piston that shoots the nail down when the trigger is depressed. He's got his hand on the trigger right here. This is the nose of the gun right down here. This has to be pressed up against the work. It has to be pressed up against something in order for the trigger mechanism to actually fire the fastener out of it. So what happens is there's a spring tension in here that causes the nail clips to move forward as each nail is directed out of the nose of the gun in this direction, and that causes the clips of nails to advance. There's a piston right up in here that very quickly comes down and pushes the nail out. Basically, the risks involved here, again, when you depress this trigger up in here, there's nothing to it. It's not a pressure switch. It's just a very light switch that feels the same whether the tool is in use or not. So the primary safeguard is the fact that this nose of the gun has to be, you have to apply pressure to something in order for that switch to actually activate. So you see guys walking around the job site, again, carrying a tool like this. It's almost like carrying a handgun. I took a gun safety course, and when you're not actually using the gun, then your finger should be up on the side of the gun, not on the trigger itself. So the hazards would be accidentally having your finger on the switch and accidentally brushing the nose of this gun against your leg, perhaps, while you're carrying it and you're swinging the tool. Other hazards are, let's say he was nailing right here on the edge of this piece of wood right here. Wood has knots in it, and knots are very, very hard. And when the nail goes into the work, naturally, it is just like anything else. It takes the path of least resistance. So if it encounters a knot, then the nail will deflect to one side of the knot or the other. So if he were nailing right here and his arm were in that position, which it wouldn't be, I'm just using this as an example, then the nail can actually, if it hits a knot, it can deflect out. And if he's holding the piece of wood with his hand at that point, then he can essentially shoot himself right in the hand unknowingly, or unintentionally, of course. So those are that's the basics of how a pneumatic tool works, and some of the hazards that are associated with that.
Okay, great. I don't see any other questions in the queue, so why don't we move on with the presentation? Thank you, David.
Okay. So slide 25, pneumatic tools. This is a connection from. I'm assuming that this is probably the air source, the compressed air. So this leads to a air compressor, and this leads to the tool. So these two interlock, and to prevent them from coming apart, in this particular case, they've used a wire so that these two components cannot disengage. This is a different type of connection for a pneumatic tool. This is the female end. There's a male end that sits right in here. This sleeve is drawn back. The male end fits into the female end, and then this sleeve goes back into its original position, thus locking the two air hoses together. This is connected to the hose itself with this coupling down in here. A hose clamp is unacceptable because it can wear through the hose. As it wears through the hose, it can cause a leak. And when these hoses are unattached, but there's air flowing out of them, they can wave around pretty violently through the air. So it can be dangerous. Pneumatic tool safety. This is the muzzle. This is an exploded view of a nail gun. This is the portion of that nail gun that gets depressed up against the work while your finger is on the trigger, and then the nail comes shooting out. Okay? And this will not work unless, in fact, this is pressed up against the work. Compressed air cleaning. Don't use compressed air for cleaning, except when it is reduced to less than 30 pounds per square inch. with effective chip guarding and PPE. Again, PPE is personal protective equipment, such as eye protection. This basically, what you see here is you press this trigger and air comes shooting out the end. And it's a very fast, very convenient way to clean things off. Under higher pressure, particles are naturally flying around with much greater force. So that's why they have the 30 psi rule. Liquid fuel tools like chainsaws. Again, main hazard is fuel vapors. Use only approved containers to transport the fuel in. And just common sense stuff. Before refilling a fuel-powered tank, obviously shut it down, don't fill it while it's running, and allow it to cool before filling it. All right, this is a powder-actuated tool. Okay, and this is a tool that would be used to fasten something to a hard surface. For example, if you're trying to fasten a piece of plywood to concrete, or a metal stud to concrete, or any number of different things. This uses a charge that looks just like a bullet. It looks like a blank, and it uses gunpowder as the charge. And when they say select a powder level right here, basically what that means is there's different levels of power that are associated with the actual charge. So when you buy them, you'll have, for example, you'll have a red, you'll have a yellow, you'll have a green, and that's marked on the box, and it's actually marked on the charge itself, and that is what dictates the amount of power that's in that charge. There are some definite hazards with regards to something like this. There's a fatal fact. Typically there's a photograph right in there. I don't know why it's missing. But basically there was a wall. I believe it was plywood with metal studs, and one worker was on the side of the wall fastening the plywood to the metal stud, but he missed the stud, so therefore it went just flying through the plywood, which will happen. I mean, something this powerful will go right through plywood and just keep on going. The worker was standing on the other side of the wall, and it hit him. The nail hit him in the head and killed him. So there's some definite precautions that you need to take when using something like this. And this is a good example. That's a charge right there. And what you'll see is different color. You can't see it here, but you'll see a different color on the end. You'll see a yellow or a green, and that dictates the power of the charge, which again is on the box when you purchase it. This is a good example of how a powder-actuated nail in a charge just went right through a piece of plywood. This is the residue left over from the powder, and the nail just went right through it. So, safety tips: don't use an explosive or flammable atmosphere. Inspect the tool. It's like anything else. 33. The capacity of the tool. Yeah, sorry, wrong slide. So just common sense stuff here. This is the slide I meant right here. The capacity is this is a jack, of course. Capacity on the jack is marked right here. But you know what? Over time, you can't see what it says. So that doesn't mean that you're going to throw the jack away. So a lot of these labels and markings on tools get worn off with usage. So you can't always see what they say. And then you just rely on the fact that you know the tool, you know what it is, and experience. This is what's called a screw jack. Jack capacity, again, it's marked on the side. That's just painted on there, not engraved. So it gets worn off pretty quickly. All right, now this particular photo, what they're saying here is to put a block underneath the jack when the foundation is not firm, between the jack and the cap. Now in this particular case, this is the handyman jack that they're referring to is right here, and you can see it's resting properly on a railroad tie. They must have just jacked up this other side here. So this is called cribbing. So they're supporting the load with sacks of wood, and that's called cribbing. And this is done properly. A good example. All right. Summary. Hazards are typically the result of improper tool use, which is, I certainly agree with, and not following proper protection techniques. Inspecting the tool before each use, more often not, guys will just pick up a tool and use it, especially if it's theirs. Using personal protective equipment, of course, that doesn't always happen. Using guards, of course, common sense, but that doesn't always happen. Properly storing the tool, using safe handling techniques. And I think that is the last slide, so we can do a final Q&A.
Okay, we do have some questions here for you, David. Mirna asks, are there power tools that do not function without the safety guards? Any manufactured with safety features built into them?
Not that I'm aware of. All the tools that I've ever used, you can take the guard off and the tool will still continue to work just fine. That's a good question, but not any that come to mind.
Okay, thank you. We do have a question here that goes back to the powder-actuated tool section. Can you just go over again what powder-actuated means and what is the powder level?
Powder-actuated means that it's like a bullet. It's the exact same. Hang on a second. It's the exact same principle of a gun. The charge is placed. Let me try to get a better photograph here. That's a picture of a charge. It looks like a bullet. And here, hang on. I guess this is the only photo I have of a powder-actuated tool. The charge gets placed. I'm not sure in this particular photograph, but it looks like a gun. It operates the exact same way as a gun. You depress the nose of the tool up against the work. You pull the trigger. The striking pin strikes the charge, and it forces the nail out in this direction into the work. The charges are based on the power of the charge. Again, there's a charge, picture of a charge, right here, and it's based upon the type of gunpowder that's within the charge that makes it more or less powerful. and they come in different ratings, which again are marked, color marked, so that you can tell what it is. So.
Okay, great. We have a question here from Myrna as well, and it deals with a private homeowner. David, if a private homeowner provides a table saw that the contractor removed the guard from, and the contractor was subsequently injured, is there any liability? And you don't know all the facts, obviously. Do you see any homeowner liability where the homeowner had notice of the same?
If private homeowner provides a table saw that the plaintiff removed the guard from and was subsequently injured, do you see homeowner liability? I wonder if this is my case. I have a case with this exact same scenario. I don't think so. I mean, I think it depends on the skill level of whomever it is that's operating the saw. Did they represent themselves as a professional carpenter? Are they licensed? What is their skill level? I mean, it's very clear based on OSHA regulations, based on the manufacturer's instructions with regards to the tool, that the guard is not to be removed. So I can't see where the homeowner, if it's a homeowner supplying the tool and the guard was on it and it was in good operating condition prior to him placing it in the hands of the operator of the tool, then I can't see where the homeowner would have a lot of liability there, in my opinion.
Okay, excellent. Thank you, David. Are you seeing any emerging trends right now with the use of power tools and just in general in the construction industry? Are you seeing more cases as opposed to the past in a certain area, or are people becoming more careful with the operation of power tools and the rest of the types of tools that you covered during today's presentation?
Well, I know that with regards to the pneumatic tools, the nail guns, probably a few years ago, maybe 5 or 7 years ago, the manufacturers started to make them in such a way whereby they could not be rapid fired. In other words, hard to explain, but you have your finger on the trigger, you put the muzzle of the tool up against the work, and a nail fires. And typically, you would just keep your finger on the trigger, keep it completely depressed, and you would just press the muzzle up against the work, one nail after the next, boom, 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 boom. Now, a lot of the guns, you have to not only take the muzzle off the work, but you also have to release the trigger, pull it again, and then depress the muzzle up against the work in the next place that you want to fasten a nail into. So it must have been based on numerous accidents relative to pneumatic tool safety, but it makes the work much, much slower. And you got to remember that these are tough times. There's not a lot of guys buying new tools, so they're just using the tools that they have, or they're buying used tools and whatnot. So other trends with regards to power tools, I've seen something called saw stop, and that is a table saw. It's a device that was invented for use on table saws. I'll get to, and basically it's meant so that if you took your finger, and I don't know anybody who would ever do this, and I know of at least one suit as a result, but basically somehow the blade senses that it's not wood, that it's actual human flesh that's being pressed up against it as it's rotating, and it causes the blade to stop immediately prior to causing any damage to the finger or whatever else that you're putting in there. And so I've seen that. I've never seen it in use, and I hope never to, because I think it's a horrible idea. I can't see how that would work 100% of the time. So, I've seen the biggest change I've seen is in the pneumatic tool and the necessity to release the trigger before nailing the next nail. Other than that, things seem to be pretty much the same as they have been for a while now.
Okay, thank you for that overview. Do you have any remarks that you'd like to make kind of to solve today's presentation?
Well, I think that the best thing that the attendees here today can take away from them is a better knowledge of power tool safety, so that when in fact they get a case that involves something like this, they'll be a little more knowledgeable as to what questions to ask, and was the tool guarded, or take a picture of the tool specifically, this and this, based on the nature of the accident. So I think that there's a lot of construction accidents out there. I do a lot of construction accident work, scaffolding, power tools, ladders, all that kind of thing. So I think that attorneys can take what they've learned here today and in other classes that we offer, and use that, to ask the client be more informed, be able to ask the client more intelligent questions, and be able to gather data early on before the tool, gets, thrown away, or before, the guard gets put back on it, as the case may be.
Okay, great. Thank you so much, David, for a great presentation. I just want to wrap things up here very briefly. First of all, as I said, I'd like to thank David for a great presentation. He put a lot of time and effort into it, and I think that came through during today's program. I'd also like to thank all the attendees who took time out of their busy schedule to spend an hour of the day with us. We host these webinars approximately 3 times every month, and we've gotten great feedback from the legal profession about them, so we're going to continue to move forward with them. If you'd like to speak to David about a specific case or project, you can please contact us here at 800-523-2319, or you'll be getting an email from me at 3:30 p.m. Eastern Time today, kind of just a follow-up thanking you for attending. You can respond to that email, and you'll be able to get in touch with me that way. We'll be sending out a link to the archived recording of this webinar tomorrow morning. I'll be sure to include a copy of the PowerPoint presentation that was part of the program. This and all of the archived recordings of our previous webinars appear in our Knowledge Center, which is on TASA's website, tasanet.com. On the home page, just click on the tab that says Knowledge Center, and it'll take you right to the webinars for legal professionals. If you have any follow-up questions or comments, please email me at mhyde@fastening.com. We do take all the comments that come into us and make these programs better, so please feel free to send me a note. And please do take time to fill out the survey that will appear on your screen after the webinar is over. That helps us as we move forward with the webinar program as well. So thank you again, and we look forward to seeing you at future events.
Thank you.